we're going to be talking about how to prove that a quadrilateral is a parallelogram. What we've been talking about in the past is some different things on how to actually identify them and some of the properties of quadrilaterals and parallelograms. But now we're actually going to prove them. Okay, so um, we have some different theorems here, and that's what is listed below. They're very self-explanatory and very easy to understand, but they are theorems that we can use in proofs of parallelograms. So we have show both pairs of opposite sides are parallel, okay? And then show both pairs of opposite sides that are congruent, just like that. Show both pairs of opposite angles are congruent. And then show both one pair of opposite sides are congruent and parallel. Okay, so we don't necessarily need to work with all the sides if we were to prove that these two are congruent and parallel, okay, or these two are congruent and parallel, then it would be a parallelogram. Okay, and then show the diagonals bisect each other, meaning that this part of the diagonal is going to be congruent to this part of the diagonal. All right, so before we even continue on to any of the other examples, or any of the examples, get these written in your notebook. This is a very important aspect of today's lesson, okay? All right, so from there, I have a couple examples for you. It says, what theorem can you use to show that the quadrilateral is a parallelogram? So we have this first one that we have angles 75, 105, 105. So looking back at our theorems, which ones can we prove? Well, we could use number 3. Okay, so this could be, in this case, theorem 3, or opposite angles are congruent. Okay. All right, so what I'd like you to do in your whisk tonight is just name the theorem. This is very easy, a very easy question. Just do number 2, 3, and 4. Name the theorems that you would use in these particular cases to show that a quadrilateral is a parallelogram. All right, so we can use these to actually solve a lot of questions when we're working with this, and a lot of times they're algebra problems like you've seen in the past. So for what value of x is the quadrilateral a parallelogram? All right, so from here we're actually going to need to set up an equation. So we know from the from our theorems that when we're working with angles, okay, we have show both pairs of opposite angles are congruent. What value of x would this quadrilateral have to make it a parallelogram? So one of the things we need to do first is think about what are the values of the angles inside any parallelogram. Well, that would be 360. We also know that supplementary angles, like these are right here, are going to equal 180. So we can actually use that information plus the theorem we know to solve this problem. So we can actually say 5x minus 7 plus x plus 1 equals 180. All right, so then we're going to have to solve. So we have, let's combine our like terms. We have 6x, and then negative 7 plus 1, we have minus 6 equals 180. Add 6 to both sides, and then we'll get 6x equals 186. divide both sides by 6, and we're going to get x equals 31. All right, so there is one example of how we can use it algebraically. Okay, another example. For what value of x is the quadrilateral a parallelogram? Well, what do we know about the diagonals? Diagonals bisect each other, which means that this value can equal this value. So then we can set these two equations equal to each other. So we have 3x minus 11 equals x plus 5. All right, combine like terms. I'm going to put my x's over here, subtract x to both sides. So then I have 2x on that side, add 11 to both sides. So 11 plus 5 is 16. And x is going to equal 8. All right, so that is all I have for you today. If you guys have any questions or comments or concerns about anything in this video, just please let me know. Make sure that those theorems get put into your notebook and that you answer those questions that I previously talked about. All right, thanks guys.